I feel like I need more tools to figure this out really. And I feel like actually I think I had done something like that before, in terms of trying to understand. I had a video trying to understand um, this notation here. And but so I don't know how long have I been thinking about these, and it just, maybe I shouldn't spend so much time on it, but it just bothers me, and I really want to try to figure it out somehow. What I did figure out now is that obviously these, so this is the oracle, is actually causing entanglement. So you can see the block spheres here. They are not like fully green. The edges are a bit lighter, and so you can see it here better after applying a switch X. The switch X thing, that the actual line, it doesn't reach the surface of the sphere. So that's an indicator that there's entanglement. And so this sort of relates to one idea that I've been uh, kind of having in my mind, which is then kind of, it goes back to the Hello Quantum game from the Kodoku, where he explains the Control Z operation in three different ways, and the last one is basically um, as a flip between these and these. And if I remember well, these are indicating correlation. And here, those are the qubits, and this is sort of the Z. I think this is, I should probably use different colors for everything. So this is basically, here you've got the Z measurements, the Z observable. Here you've got the X observable, and those are kind of correlations. So uh, on here would mean that they disagree, which is correct because this is off and this is on, etc. Right? So it's a bit like, you could see what this is telling me is you could somehow see the control zeta as basically affecting the kind of correlation that there is between observables. But I'm not so sure if that's helpful somehow, because it is definitely, there's something that tells me that it is helpful, because it has to do with mm, it has to do with these operation affecting the X observable this way, as in like that they are somehow correlated, like the Z observable, uh, this being the Z observable, and this being the X observable. But I'm not entirely sure. So let me kind of walk you through these again once more. So what I've got here, big mess again. So basically, you start with a 111, then you go into superposition, and then that's what you have. So this is the Z observable superposition, and with a particular configuration of phases. That's because it's a 111. If I take those away, then then basically they're all like, all the phases are, because that's like a plus plus plus, so all the phases are 0. Mm, now, uh, then we've got, so that's the Z observable, that is the X observable, and I don't know why I have another Z observable here, so I'm just gonna get rid of these. I have block spheres. Then I've got basically the actual oracle, and I have more block spheres. Then I've got like a Z observable. I put it orange again. Z. That's X. And then this is, and then comes the amplitude amplification. I got the blocks here, and basically the final uh, Z measurement. I think you can do one more step, but that's clear enough that it's working out. And so I can't figure this out. I'm trying to I'm trying to understand if I can intuitively explain what's going on. But I feel like I'm missing some information. I feel like I'm missing something else, or maybe a different, fresh perspective. What basically what this is telling me is that what I currently have in my mind is this operation, the oracle, is basically, if you take a look at the X observables, the blue ones, so it's taking, here we've got 100% certainty, and after applying that, you've got a bunch, like sort of it spreads out, but like only 6.2%. And the reason I think this is this way is because you're taking a chunk. You're just saying for that particular configuration 101, right? So for that particular configuration, shift the phase, and so that's these here, and the Z observable, that's this phase shift, which kind of results into creating this kind of superposition, which is not an equal superposition. But I kind of feel like, where is these information? Like, I'm missing in the X observable the information that this is somehow related to this operation, to this control Z operation. On the other hand, this kind of superposition that we see in here, it's like almost it's like, if this is the state that maps to that superposition, then this is the state that maps to that superposition, that it's kind of almost a minus minus minus. Yeah. And to some extent, what we're trying to extract out of this is the difference. I don't know if this would technically be a difference, but if you think about what color to choose, if you think about this superposition and this superposition, the only difference is that phase, and that's exactly what we're trying to take. That's exactly what we're trying to take from the phase. So from the phase dimension into the amplitude dimension. Now, so if we could have that, if we could basically minus the if we could minus the superpositions and then just be left with that, then it would kind of be trivial to then apply Hadamard's and just, you're just moving it from the X observable to the Y to the Z observable. And that's kind of why this is generic enough, right? In the sense that it doesn't matter what's your initial superposition, because what you're trying to extract is the difference between this superposition and the one you're creating by just applying the oracle. And this subtraction must be happening here inside this operation, because otherwise I don't see any other Hadamard anywhere that would kind of justify the flip. So I think I definitely need to open that up. So get rid of this and then do it the traditional way. So gonna basically apply later Hotmart. Then I'm gonna apply a controlled, it's not needed, control Z, and then another layer of Hotmarts. So that's it. That's the same effect. Um, exactly. So now basically I should simply dive into this. So what happens, obviously, when you do the Hotmarts, is that those things get flipped, right? So basically, the X operator, so all the stuff that is in here is now going to become part of the Z operator, operator observable, and this is going to become part of the X observable. Mm-hmm. The X observable. So and these, I'm trying to think. It's difficult to think out loud, especially when it's such a long chain of thought. So and I said this is almost the same like these, correct? Um, is that correct? This is almost the same like these, but with a minus. All right, and and now, and now after we've done the Hotmarts, we're gonna have. So if I put the amplitudes in here, I'm gonna try to keep it short just with the amplitude so I don't um, clutter it too much. And this is gonna be, yeah, so here we've got now the Z. I'm stupid. So they should all be after this layer of Hotmarts. Yes. So now we basically got them flipped. So this was in the X observable, now it's in the Y, in the Z observable. This is now the X observable. And so the next operation, and let me try to be consistent with this. So this is the Z. This should be more orangey. That should be more orangey. More actual orange. This is this, and then kind of bluish. This is this. And now and now I've got, okay, so now I've got sort of a control Z, and the way this control Z looks like, that's an important thing to, an important observation. This is not the way this is designed. It's a full dot, like the control Z. Like this is because, so this is something that it's not always like that. This depends on your initial superposition. That's why if I get rid of these, for this to really work well, I actually have to, because you see now it doesn't work. So for this to work well, I actually have to surround the the circle is too long already. I actually have to surround. Can I just place it somewhere? I actually have to surround that with X gates, because basically I need for this to be 0, 0, 0, right? So and I can't do it like that with pure control, so I have to negate the 1, 1, 1 in order to do so. So if I do that, now you will see that it will work. So yeah, now you got everything, and that's kind of more the traditional implementation you see, just because it makes the initial superposition easier to see because it doesn't have, it makes the actual difference between that after applying, when you apply the oracle on that superposition, you kind of see it easier because that superposition has all the phases are 0, so you're only gonna with the oracle phase the item you want to look for, so it's easier to explain. That's why people usually use this construction. Craig uses the other construction because then he can rid of these he can get rid of these, and then he can compact the expression. So we'll put them back here. He can compact the expression with his x-axis controls. But let's say you could even start with that. Let's say you start with that seed, and then you basically create the superposition, applying the Hadamard gates, blah blah blah. For this to work out, you would have to match that. So this then would have to be a or control like this. Yeah, you see, now it now it works again, right? So this is just because of the nature. So that's exactly what makes me think that. So this is chosen by design. This way. This is the way the algorithm is designed. So there is then a connection in here that I want to figure out now. Trying to figure out why. So what's the effect that this has? Because this definitely has to do with that subtraction that I'm talking about somehow. So now what this is, let's walk through what would this do intuitively. So this would definitely now shift the phase from the x observable part of this superposition 1 1 1, right? But if we come back to what we're saying the oracle is doing, the effect of the oracle. So we're here. I'll use my mouse. I keep switching. Okay, so the effect of the oracle in the x-axis here is that we're spreading out. But now here we already spread, right? So here we've got an actually we've got an equal superposition. We've got an equal superposition. So these should in theory somehow fold. Should it? Or not fold, but it should basically modify some kind of amplitude or a set of amplitudes, right? Now, how is it possible it actually flags the exact difference, right? Because then the last layer of Hadamard, this is just trivial, right? It's just gonna flip again the observables. So we don't really care about these. This is just to get the results where we can actually read them. So basically, this is what we have in our. Let's put some of these guys in there. I feel I kind of need. I'm missing some information, or missing something that's like, now it's obvious what it's doing, what is happening here. So we're like that. I mean, they are entangled, right? And after that, after that operation, they're not entangled anymore. Interesting. And you can see the effect of the Hadamards here. They're just mirroring. It's not they're mirroring. They're not really mirroring the way that I would expect it at a qubit level. But anyway. So what is this doing? This control. Z. I feel I'm just doing kind of repeating the previous video completely. um, kind of doing the whole thing all over again. But I'm hoping to identify where am I missing something, because it's super difficult to wrap your head around what's going on here at that point now, based on the fact that um, yeah, I mean, how is that? So let's take a look at these superpositions. This, what does this look like? This superposition. This superposition is like, oh, these two are, I say, like open, open, closed. You know, there's nothing like that. No. When I scroll, I can see where I used the eraser. That's funny the way it's implemented. That's so messy. Okay, um, it's like if they just painted with transparent ink. That's the. You see here? You see here? Here. Anyway, um, oh my God, how can this be? Looking at it from the wrong perspective, or what? If I if I if I do this, then it's obvious that's what's happened here. So, and then this with the Hadamard gates, just move it to the X observable. That's what we see here, and the N. Huh. Huh. So it seems like this is somehow having an important role here, right? Mm, why is it now moving with me? Come on. Maybe because I'm sort of like far off the edge. Uh, oh man, it's just so complicated. It's just so unintuitive. It's a control Z, so what it should do is I know what it does in terms of changing the phase of these guys here, right? So if I duplicate this and put it here, that's what it does. It just flips that phase of the Y observable. But that phase flip causes this to happen in the X observable. Why is that? Oh. Why is that? Why is that? Uh, I don't know if I probably should save you the minutes of just listen listening to me grumble about this. Come on. missing like a line of thought. I just don't know where I felt like I'm at a point where I don't know what's the next string to connect, or what's the next thing to grasp. To grab, because this is a control Z, so obviously that's the effect. But the effect it has in here is that it increases the amplitude towards the. It's not towards the one. It's towards the element. It's towards the actual difference of the superpositions. The initial superposition and the one that you created by doing that. And because you did that on a state that was basically all concentrated on minus, 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 right? Sorry, no. You did that here. That's where you applied it, yeah. Sorry, this is the one. This is the one that basically has elements of a superposition that, and I think the elements of this superposition, wait a second, it's almost as if, of course, it's almost as if these is creating a superposition, like if you would have like a not like 1 0 1, and you would create, and then you would like all Hadamars, that's the superposition you would create, right? Oh, wait a second, that's one, there's something there. There's something there. That on one side flips, of course, that, but it creates that kind of superposition. So if I would, let's see if I can open Quirk, like a clean instance, and if I do like these, right, and then I create Hadamars. So I'm calling these like closed because it just for me to easily remember what's in here. It's like closed, closed, open, open, yeah. Because the phases are kind of touching each other, so it looks like a gate that's closed. This looks like a gate that's closed, and this looks like a gate that's open and open, closed, closed, open, open. And here, yikes, almost. That's not. It's open, open, closed. Oh, wait a second, but I should negate it because this is, the seed is not 0, 0, 0, it's 1, 1, 1. So if you start with 1, 1, 1, and then you do the pattern 1, 0, like 1, 0, 1, and then the Hadamars, then no, because then you get like this weird pattern, like no, that's not okay. That was the wrong. For a second, I thought that the effect that a kind of control Z would have on the X observable is to create a superposition similar to, yeah, to what you would have created otherwise. But it's not, because it would then be an equal superposition, and it's not correct. Of course, it's not correct. There must be a superposition because you're basically like implicitly, because of the implicit usage of that, there must be a superposition, right? But the distribution is not equal because you're just conditioning on one particular state, 101. So it's almost like you take a portion of that and then, 101. Yeah. Whereas here, you've got in the X observable a fully equal superposition in your X observable. And so when you apply a control knot, you're it's almost like you're saying almost like you're saying what? That that you're kind of it's awkward. It's really awkward. I can't explain. I can't what does the control do? Ah, it's just frustrating because I'm maybe just banging my head against like something that I should be banging my head against. mm. Because one of my fears is that the particular set of gates that's chosen is kind of chosen in hindsight after doing the math, which is what happens mostly with some variational algorithms, and so that makes it impossible to explain intuitively. But somehow it feels like Grover should be explainable intuitively. Um, so, oh, oh. But so I'm struggling with explaining the effect of a controlled Z on a next observable that is a superposition. So let's say I create a superposition like this. Now I have a superposition, and now I want to know what's the effect of a controlled Z on the X observable. So the X observable here, right? If I now do, I should also make a gate and say switch X. So if I switch X and show the amplitudes, so it's 0, 0, 0, right? You've basically exchanged that. Now I apply a control Z, and now I take a look at the amplitudes again. Okay, so they've wrong. Wrong. I wanted to see the effect because that's basically the same we're seeing here, right? So I'm basically the same we're seeing happen here with this observable, because we've got everything concentrated in one, and then it creates a superposition. I wanna no, no, what I wanna do is I wanna get rid of these. So in sort of the initial state 0, 0, 0, if we take a look at the x observable, we've got an equal superposition. Okay, we've got an equal superposition. If I apply a control Z to that, we still got an equal superposition. That's interesting. Because I know that there is nothing, I can almost backtrack, and I know that there is no such possibility, so it doesn't affect. But if I add x gates in here, okay, so now what it does is, okay, so it actually flips the phases of everything, of the 0, 0, 0 seeded superposition, or 0, 0, 0, yeah. So it's almost like these should, on the x observable, shift the phases that match the original superposition. Let's see. Okay, so let me clean that up. So what I'm saying is, let's take it step by step, that this operation should take these, because it's like 1, 1, 1, so you've got x, 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 right? So it should take this superposition and flip the phases only if they match. Only if they match, so only if they match. But where? In the x observable. So we're taking a look at these, and we're taking a look at these, right? So this is 0, right? I think this is 0 by convention, and this is 180. Yes. So this is 0. So let's start. Let's start with the first two is 0 and 180. So they should be 0 and 180. They should be flipped. 180 0. Good. This is 180 and 0. This is 180 0. So it should be 0 and 180. Correct. Let me circle them more. Those are the ones I'm taking a look at. This is 180 and 0. 180 and 180. So only this one. So 180 is flipped to 0, and here and this one is not. So is that why it sucks up amplitude then? Huh. Because the rest are flipped. So this is 100. So this is 0, 180. It matches 0 and 180. Whoopa! Oh crap. I think it was just like that. Okay. No. Oh, I messed up. Which one was it? Oh my god. I think it was this. Yeah. Good. Okay, so it seems we've got, that's interesting. Basically, we've managed to, it's almost like if you don't care about these. So we've moved into the X observable, the superposition that actually contains, oh come on, ooh, oh, I lost all my circles. So the superposition here, right? And this is sort of our initial superposition. The one here, we've basically created the superposition. Oh, come on. Let's start again. So here is our initial. Here is the one we've created that looks like the original but has that phase shift, right? And we're trying to extract that phase shift. So, but we have it in the Z observable. So we've managed to basically put it in the X observable here, yeah, just by applying the Hadamard. So remember, everything else here in between our measurement is sort of debugging extra stuff. And then we're applying, that's interesting. So what that is doing is it's flipping the it's flipping superpositions. No, it's, oh my god. Maybe it makes sense to use Craig's notation again, actually. Oh, because what Craig's notation would mean is that you're flipping the phase of everything. Oh my god, it's acting at the superposition level. Wait a second. That's gonna hurt. How can I not lose that? So, and in the places where it doesn't match, it just sucks up the amplitude. But why does it suck up the amplitude there? Oh my god. Oh. Mm. It's almost the effect it's having on the X, but here the effect that this is having on the X observable is not. So if I would apply the same logic, I would now be saying that the this thing is going to apply a phase shift in here in the elements that match the 101 seated superposition, and for those where it doesn't, it sucks up amplitude, which is technically what is happening, right? Because there's no match in here, so it's really sucking up amplitude. Because if I create that superposition, the last element has a zero phase shift, So it matches this one, so it flips it. The rest don't match because they are empty, so they just get filled up with amplitude. Oh. So that would mean that would give it a whole new meaning, because what I'm trying to say is basically that, so remember, when you're in the superposition, right, what what these kind of, so what a control Z style operation does is it basically phases one element in your superposition. It just phases one particular element, that element, 1 1 1, right, 1 1 0, etc. But in contrast, what these would mean, for example, is that it phases all the elements that match a superposition created by 1 1 1, because this is like minus minus minus, right? Oh my god. Really? In which case it wouldn't do anything really, but if I surround that with, no, surround that with Z's, then it does. Oh, then it flags as it would be like minus minus, plus plus plus. You need the Z's because that's how you kind of do the equivalent of the X on the Z axis, but you do it on the X axis. So Craig's X axis control behaves the same. It's just that if you take a look at like then a Z axis control is just, if you look at it from a Z axis perspective, Z observable, all you're doing is you're flagging entire superpositions, and you could think of these as having this sucking effect, like if these would have a, if I would apply a Z here, what would happen? Nothing. No, 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 no. I mean, yeah, that's basically Grover's, the way Craig puts it. If I just put like whatever combination here. Oh, sorry. I gotta keep it this way. But if I'm just zetting, because I'm doing a bunch of them, why isn't that working then? If I just use Z gates, why aren't they, some of these elements getting or sucking some property? Here they are, but not like these. No, that seems a bit stretched. That seems a bit stretched, honestly. That seems a bit stretched. Let me clean that up. That is definitely a bit stretched. Back to square. So back one step, not to square one, but back one step. So let's think of in terms of because something's damn happening to the what. What I could add here is I could try to take a look at what's going on with the Y observable, but I don't think that would help. So the Y observable would require that we do something quick here, which is according to this, the Y observable is the S transpose H. So I would say this is the S minus 1 H, S minus 1 H, S minus 1 H. And if I now do make gate and I say it's 1 and I say switch to the Y observable, and now I get rid of this. So let me make sure that it works just before. I'm gonna put a so an I, right? If I start with an I, that should be either 1 or 0, I don't know, but if I add a switch to Y and the chances and a switch to Y, yeah, so it seems it works. It's all zeros, right? If it's all minus ones and it's all ones. Yeah, that works. Neat. Okay, so what happens in here? So I'm trying to understand what's the effect here. So it's getting nasty. So this is our center point. Here we've got the X. Here we've got the Z, and I'm gonna add the Y. Because we've changed these two, but I basically want to add the Y now. So I want to add. So I already have to clean that up. Useless. And oh my god. That's messed up. What happened? What is before the Hadamards? Switch Y, switch Y. Something's off here. Something's not working right. I think the switch Ys don't behave well here, really. Oh, of course. Because I should have a... Because I should do the switch Y back, which is basically the opposite. So that's why it's not commuting. So now I should do these, and I should make a gate. Call it switch Y back, because here I have two operations, so now I cannot use the same one. Oh come on, but it just overrode that? Yeah, and now I just have to add some. It seems like it seems it's just because if I rename the same region, it overrides. So if I just now do 3, 4, that is switch Y. Exactly. Now I get rid of all these. Get rid of all this. Get rid of all this. Good. I get. Where am I? Oh my god, I've lost the. So before the Hotmarts, I do switch Y and switch Y back, and I add this in between here. I don't think this seems to be working. So this is in Hotmart. Should be Hotmart in this. Hotmart in this. Switch Y back. Doesn't seem to work because it's messing up. It's messing up. It's messing up. I got it backwards. Come on. Following gate. That's not the Y observable. That's something else. My god. Is it? Or because the S is half. And then the harmonic gate. Yeah, okay, but that's basically what. How to measure on the Y basis. Ah, you see, it's H and S, I think. Measure Y. Oh, you see, it's H and S. Oh, but you first apply the S and then you apply the H, because that's the unitary. I guess I was correct. So it's using this language, measure Y is equivalent to applying H and S, then measuring in the computational basis, where S is the so-called phase gate. It is also equivalent to applying H S sharp to the quantum state vector and then measuring Z. The correct state would then be found by transforming back to the computational basis, which is by applying S. Oh, I'm stupid. Okay. So, let's do this again. So, I would say S minus 1, S minus 1, S minus 1, Hotmart, 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 and then Hotmart, 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 S, 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 because it's the opposite gate. Okay, May gate. So basically, the 1, 2, it's switch Y, May gate 2, 4, 3, 4 is switch Y back. Oh my god, now I got... Okay, I got many of those, whatever. Okay, so... No, how can I... Because I'm not using a mouse or whatever. I'll clean that up, 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 clean that up. Now I got the correct things, the correct ones. So, before the hotmarts, I'm gonna use a switch Y and a switch Y back. And that doesn't affect my result. That's good. That's good. Okay, so that looks like this before the hotmarts. That shouldn't matter, because after the hotmarts it should look the same, so I'll just move it here. Exactly. Oh no, wait, it does look different, right? It does look different. Yeah. It's mirrored. So the hotmart is mirroring that. Interesting. Anyway, I'll switch Y back, and we'll do the same after the switch Y back. That's getting so messy that I'm still amazed I haven't lost my... Okay. Whoa. That's crazy. So I was basically trying to compare now this versus this. So it's what you can see in the Y observable after the controls, and basically a mess. The phases are flipped. No, the faces are messed up totally from that perspective. From that perspective. So that doesn't really help, I think. That definitely doesn't help. I'll stop here and I'll give it another try in another video. Perfect.